Next Lewis structure we will draw is for the molecule sulfur trioxide, SO3. Again, the procedure is first select the central atom. Sulfur, which is written first in the formula, and also there's only one of it, would be the best choice for the central atom. So all the other oxygens will be attached to the sulfur in our drawing. The second step is to add up the total number of valence electrons in the molecule. Again, I look at the position of sulfur in the table. It's in group 6A, so that's going to have 6 valence electrons. Oxygen is also in group 6A, so each oxygen atom is going to have 6 valence electrons. However, you'll notice that oxygen has a subscript of 3, so that means that each oxygen atom brings 6 valence electrons to the table, so we need to multiply 6 times 3. So we add up our total 6 plus 6 times 3, which is 18, gives us a total of 24 valence electrons. Next, we start drawing our structure. Place the sulfur in the center, attach each of the oxygens to the sulfur with single bonds. Now currently we've got 6 valence electrons shown in the drawing because we've got 3 of these single bonds shown. And so we have a remaining 18 electrons to show in the drawing. We want to distribute electrons to each of the terminal atoms first so that they get their complete octet. And we're going to keep passing out electrons until we have used up all 24 electrons. Doesn't matter which oxygen I start on, so I'm just going to start on the left side. And so this oxygen already has 2 electrons that it's sharing with sulfur, so I'm going to give it an additional 6 electrons just by drawing unshared pairs of electrons around the oxygen atom. Now I've got a total of 12 electrons shown in the drawing. I still have another 12 out of 24 that I can draw on, so I'm going to move on to the next oxygen and add on an additional 6 electrons. And then I'm going to move on to the last oxygen and give it a complete octet as well. The goal when I've finished my drawing is for each atom, terminal atoms and central atom, to have a complete octet of valence electrons. So I should go around and count and make sure that each atom has 8 electrons in contact with it. I also must keep in mind my total number of electrons that's allowed, which is 24 for this molecule, and I may not exceed this amount or have less than this amount. So I have to give everyone a complete octet while keeping 24 total valence electrons. So I go around and count. We've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I have 24 valence electrons shown, but my sulfur atom is actually only in contact with 6 electrons, so it does not have a complete octet, and that needs to be fixed. If you do not have enough electrons for each atom to get a complete octet and have unshared pairs of electrons, what you're going to need to do is take one of the unshared pairs from one of the oxygens and move it to share it with the sulfur atom. Okay, so instead of this pair belonging just to oxygen, this pair is going to be shared between that oxygen and sulfur. So what that looks like is if I just remove that, put my S back, fix that. It's going to be a double bond between the oxygen on the right and the sulfur atom. So now if I go back and count up all of my electrons, I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So there are 24 total electrons shown in the drawing, and each atom has 8 electrons in contact with it. So the oxygen has 1, 2, 3, 4 lines, that's 8 electrons in contact with it. The oxygen on the bottom has 2, 4, 6, 8 electrons in contact with it. The oxygen on the right has 2, 4, 6, 8 electrons in contact with it. And the sulfur in the center has 2, 4, 6, 8 electrons in contact with it. So I have completed my drawing because I know I have a complete octet of valence electrons around each atom, and I also have a total of 24 electrons shown in my drawing. Now you may be wondering, how did I decide that the oxygen on the right should get the double bond with sulfur and not the oxygens at the bottom or on the left side? If there's more than one possible way to arrange or locate a double bond, then you need to show all the possibilities by drawing what are called resonance structures. To draw a resonance structure, you should always show a double-headed arrow between your drawings. And we're basically going to show all the possible places that this double bond could go instead of just between the sulfur and the oxygen on the right. So another possible way I could have drawn this is if the oxygen on the left had the double bond. It only has 2 unshared pairs of electrons on it. The oxygen on the bottom still looks the same as in the other drawing, and now the oxygen on the right has 3 unshared pairs of electrons, like the one on the left originally did. There's one more way that we could draw this, and again, I'm going to attach or connect that drawing with a double-headed arrow, and that additional way to arrange the electrons is with the double bond between the sulfur and the bottom oxygen. So these are resonance structures. So if there's more than one way to arrange the shared electrons, meaning the electrons between 2 atoms, that is what's called a resonance structure, and you need to show all possibilities by drawing these double-headed arrows and then all your other possible structures.